Hi everyone and welcome to my educational channel Models Hero Math. Today we're going to take a new lesson, which is the third lesson of this channel, which is called Properties of Ratio. It is another grade 6 lesson. So what are the properties of ratio? So we have a couple of properties for ratio that we use to identify the ratio. So we have property number 1 over here, as you can see. So property number 1 says the ratio has the same properties of the fraction as reduction, simplifying, and comparing. So as you can see, let us just take it a little bit more and just simplify it into other pieces. So the same property of fraction. So this means that the ratio has the same properties as a fraction. But what are these properties of the fraction that the ratio has in common with the fraction? Like reduction, which is subtracting, simplifying, when we simplify a fraction to its simplest form, like 3 over 6, it becomes 1 over 2, and comparison, when we compare two fractions, is like the same as when we compare two ratios. So the first property says the ratio has the same properties of the fraction as reduction, simplifying, and comparison. So property number 2 here, it says in its simplest form, so in the simplest form of the ratio, the two terms of the ratio should be two whole numbers. So the two terms of the ratio, which are the antecedent, the numerator, and the consequent, the denominator, and we talked about them in the last video. If you haven't watched it, go and watch it. It's called the meaning of the ratio. So the two terms, which are the antecedent and the consequent of the ratio, should be two whole numbers. So they have to be two whole numbers as small as possible. So we have to make them as small as possible, and as small as possible means, I'm sorry, wait. So as small as possible here means simplifying. So property number 1 says that the ratio has the same properties of fraction as reduction, simplifying, and comparison. Property number 2 says in its simplest form, the two terms of the ratio, which are the antecedent and the consequent, should be two whole numbers as small as possible, which means in the simplest form. So what are other ratio properties? So first of all, before going to the other ratio properties, we have here a good remark that we have to notice while dealing with ratios. So to write a ratio in its simplest form, you should remember some of the rules. So what are some of the rules that we should remember to write a ratio in its correct simplest form? The rule of divisibility. Divisibility is division. So we need to remember the rules of divisibility, which is division, which you studied before. So we can here say that a number is divisible by. So we have studied the rules of divisibility before, and absolutely well know that a number is divisible by 2 if its units digit is 0, 2, 4, 6, and 8 or 8. It's divisible by 3 if the sum of its digits is divisible by 3. It is divisible by 5 if the units digit is 5 or 0. So we need to remember the divisibility rules so we can simplify the ratio into its simplest form. So example number 1. So as like when we deal with fractions, we're going to deal with ratios. So here, write each of the following ratios in its simplest form. So we're going to need our divisibility rules with us. So here we have 25 to 45, and we have said in the previous video that 25 to 45 is ratio, that is comparing 25 parts of something to 45 parts of something. It can be written as 25 to 45 and using the 2 sign, or it can be written as 25 over 45 as a fraction, or also we said it can be written as 25 to 45 as a word. So to make it easier for ourselves, we are going to deal with the fraction form here. So we're going to make 25 to 45 in the fraction form, which is 25 over 45. And now let's start simplifying it. So 25 over 45, they both have 5 in the units digits, right? So this means that they are divisible by 5. So we can divide by 5 here. Both of these can be divided by 5. And when we divide 25 by 5, it's going to be 5. But now we're going to write it in the 2 form. 45 divided by 5 is 9. So now we have 5 over 9 as a product of this, as a product. So 5 to 9. So can 5 is 5 and 9 both divisible by the same number, by a same number? No, they aren't. So this is the simplest form of 25 to 45, which is 5 to 9. Also, let's do another one here. Let's do this one, number C. So 48 to 18, we can make it in its fraction form, which is 48 over at the top as the antecedent and 18 at the bottom as the consequent. And then we can start simplifying it. So both units digits here are divisible by 2, right? 8 is divisible by 2 and 8 is divisible by 2. So we can easily divide by 2 here. So 48 divided by 2 is 24. And 18 divided by 2 is 9. So is 24 and 9 divisible by one number? Yep, they are, because we can divide 24 by 3 and we can divide 9 by 3, and 24 divided by 3 is 8 and 9 divided by 3 is 3. But is 3 and 8 both divisible by one number? No, they aren't. So the solution of this here is going to be 8 over 3, which we can say it is 8 to 3 in the 2 sign form. So this is the simplest form of 48 to 18 as a ratio. So let's take this one here. 30 to 20, it's actually very easy because both units digits here are zeros, and when it's 0, it's going to be divisible by 10 or by 5. Let's use 10, so 30 divided by 10, it's going to be 3. 2, 20 divided by 10 is going to be 2. So the simplest form of this here is 3 to 2. So because we don't have another number that is divisible by 3 and 2 at the same time, because 3 and 2 are both prime numbers. So this one is a little harder because it's a bigger number, but we can do it. So 2,800 to 3,500. So we can easily divide these by 100 because they both have 2 zeros at the end. So when we divide 2,800 by 100, it's going to be 28. And when we divide 3,500 by 100, it's going to be 35. Is 28 and 35 both divisible by one number? No, because you can notice that 8 here is divisible by 2 and 5 here is divisible by 5. So they aren't divisible by the same number. So this is the simplest form of this ratio. So solutions, as we have done there, if you just want to check by yourself, the first one is 5 to 9 because we have divided here by 5. Here we have divided by 2 and then divided by 5. We can just divide by 10, as you can see here. And here we have divided by 2 and then by 3. Or we can just divide by 6 using the highest common factor. And as you can see here, we divided by 100. And then divided by a 7. And yeah, the other one I forgot, that 28 and 35 are both divisible by 7, and 28 divided by 7 is 4, and 35 divided by 7 is 5. So example number 2. So here we have got another example. So it says compare the two ratios 4 over 5 and 3 over 4. So we have talked in the beginning that the ratio and the fraction have the same properties of reduction, comparing, and reduction and comparing and simplifying. So as you can see here, 4 over 5 is a ratio as well as a fraction, because a ratio is a fraction and a fraction is a ratio. So how to figure this out? So we should have, as we have studied before, we should have two denominators, which are here in the ratio, are called consequents. We have the two consequents should be the same number, so we can compare them easily. So 5 and 4, we need the lowest common multiple of 5 and 4, and it is 20. So the lowest common multiple of 5 and 4 is 20. So this is why we have made the 20 here at the bottom, or at the consequence for each of these. So 20, when we divide 20 by 5 here, it's going to be 4. So 4 is going to be multiplied by 4 here. It's going to be 16 over 20. And 4 is going to be multiplied by 3 at the top here. And it's going to be, 20 divided by 4 here, 6. 6 times 3 is 18. 5, sorry. 20 divided by 4 is 5. And 5 times 3 is 15. So as you can see here, we have the two fractions now, 16 over 20 and 15 over 20. They have the same denominators or the same consequence. So this means we can compare them, and 16 for sure is greater than 15. So this means that 4 over 5 is greater than 3 over 4. And here it says, notice, the comparing of the ratios is the same way of comparing, of two fractions. So when we compare two ratios, it is the same when we compare two fractions, because also if this was like, if it was in the form of a ratio with a 2 sign, like 3 to 4 and 4 to 5, it was like this, we can also compare it by converting them to their fraction forms. So the comparing of two ratios is the same way of comparing two fractions. So example number 3, the only way we can master this technique is by using solving a lot of examples. So here I've got, in the opposite figure, complete the following. The perimeter of the square XYZL. So as you can see here, where is the square XYZL? Here is that. So we need the perimeter, and the perimeter is the sum of all the sides, which is this plus this plus this plus this, right? So we need the perimeter. So it is, as you can see, it is a square, right? It says here is a square, and we have the sign that indicates that all the sides are equal. So this is a square, and one of the sides, as you can see here, is 4 centimeters. So this means that the perimeter is 4 times 4, which is going to be 16 centimeters, right? So we know it's going to be 16 centimeters. So it's going to be 4, because it is with the one side here, and the formula of the perimeter is 4 times the length, and the length here is 4, so it's going to be 16 centimeters. So the perimeter of the rectangle, now we have a rectangle which is ABCD. Where is rectangle ABCD? Here it is, rectangle ABCD. And as we know, the rectangle doesn't have the same number of sides. So the long side here is 5. This means that this side too is 5. And this here is 2. This means that this side here also is 2. Here is 5. So we need the perimeter, and we know the perimeter of the rectangle is length plus width, and both are multiplied by 2. So my length here is 5, and my width here is 2, and we're going to multiply these together by 2. So 5 plus 2 is 7, times 2 is 14. So now we have the perimeter of the square, which is 16, the perimeter of the rectangle, which is 14. Good. So now we need the ratio between the square perimeter and the rectangle perimeter. So we need the ratio between them. So here, what is the first term here, guys? The first term here is absolutely the square perimeter, because the first one here, so this is the antecedent, and the consequent is the rectangle perimeter. So we're going to put the antecedent first, which is this perimeter of the square, which the perimeter of square here, as you can see, it is 16. So we're going to write 16 here. Good. And the perimeter of the rectangle, as you can see here, is 14. So we can write that the perimeter of the square is 14. Now we need to simplify this. So to simplify this, we're going to find a number that is divisible by both numbers here. So 6 and 4 divisible by 2. So 16 divided by 2 is 8. And 14 divided by 2 is 7. And 8 and 7 doesn't have a common factor between them, so it can't simplify them more. So it's going to be 8 to 7. So here we need the area of the square now. So here he wants the area of the square, and as you can see, here's the square, which is XYZL. So we need the area, and we are good people, and we know that the area of a square is length squared. So where is the length? It is 4, and 4 squared, or 4 times 4, is 16. So it's going to be 16 centimeters squared. So here now he needs the area of the rectangle, and here's the rectangle ABCD. And we know that the area of the rectangle is length times width. So the length is 5 and the width is 2. So 5 times 2 is going to be 10 centimeters square. So now we need the area of the rectangle, which is here the antecedent over the area of the square, which is here the consequent. The area of the rectangle, as you can see here, there's the area of the rectangle, which is 10. So we're going to write here at the top 10. And the area of the square, which is here 16. So we're going to write here 16. And then now we're going to simplify this. So 10 is divisible by 2. 10 divided by 2 is 5. And 16 is divisible by 2. 16 divided by 2 is 8. Or we can write it in the 2 form, which is 5 to 8. And as you can see, here is the 2 sign. So here's our last one, the side length of the square to the side length of the perimeter. As you can see, here's the 2 sign. This means it's a ratio. So where's the side length of the square? This is the side of the square. And we know that the side is 4 centimeters, right? So what we're going to write here is 4, because it is the side length of the square. And then we want the perimeter of the square, so pay attention. So the side here, and here's the perimeter, and we have got the perimeter at the top here, which is 16, right? So we're going to write 16. So it's going to be 4 to 16. So both of these are divisible by 4. So 4 divided by 4 is 1, and 16 divided by 4 is 4. So the side length of the square to the perimeter of the square is 1 to 4. So remarks. So here, as you can notice that in an equilateral triangle, if we had an equilateral triangle, which is a triangle where the 3 sides are equal in length, the ratio of the side length to the perimeter, so the ratio of the side length to the perimeter is going to be 4 to 3. So it is like a formula that you can just memorize and always write when he wants you to find the ratio of a side length to the perimeter of an equilateral triangle. So in a square, the ratio of the side length to the ratio of the perimeter that you have just done is 1 to 4. Always know that it is 1 to 4. And in a square also, the ratio of any side to another side is 1 to 1, because all the sides in the square are equal. And in a rhombus, the ratio of any side length to any other side length is 1 to 1, because the rhombus also all the sides are equal in length. And here it says in a circle, the ratio of the diameter length to the circumference is 2r to 2 pi r, which equals 1 to pi. These are just general formulas to know when we have geometric shapes involved in the ratio equations or the ratio formulas. You don't have to know the last 2 ones because you are just didn't take them yet. But if you want to know them, they are just written here. So if you memorize these formulas, you're going to be so quick in doing the stuff, because these formulas are always constant and they don't change and they're always correct. So we have reached the end of this lesson. So you can try these questions by yourself. You can try to simplify these ratios to their simplest form. And the best thing here, you have the 2 form and the fraction form, and they are the most important forms. They are not important like the 2. The 2 one isn't very important here. It's just the 2 form. and the fraction form. And remember, the top number here is the antecedent and the bottom number here is the consequent. And yes, so you can just try these, and I hope you enjoyed the lesson and you have learned something new.